posters were great. I hope that you learned the chemistries all over the place. We start off with the first one, where I have... And now, magically, without using my mouth, I'm going to get the balloon to inflate. And a rainbow of colors, you will notice, are happening as the balloon inflates. If you know anyone that is 3 years old or younger, you will become their hero if you show them this. They do not have the lung capacity to blow up a balloon, and they look at all these other people that can do it. Now, you don't have the universal indicator because you don't want them to drink the universal indicator because it has the active ingredient in X-lax in it, okay? So you don't want them to drink it. It's vinegar and baking soda, all right? Now, you have to tell them if they want to taste it because a lot of times they'll want to taste it. See, well, it's going to taste a little bit of chemical reaction. We had a gassy ball and a color change. So 2 of the 3 observations for a chemical reaction. I just had another one just in case it didn't work. Okay, always on well, we have calcium chloride, which is a soluble salt because most chlorides are soluble. And we have sodium carbonate, and almost all sodium salts are soluble. But what happens when we mix these 2 together? We create kidney stones that we hope we never have to have. And insoluble solids, so what happened? A precipitator solid was formed. These are the 3 visual ways that a chemical reaction occurs. But in this semester, we talked about, but we know better now in Chem 220. We know that this is an insoluble solid, but a little tiny bit of it is soluble. So that calcium carbonate solid is in equilibrium with a very small amount of calcium ions and carbonate ions. And when you take carbonate ions and you mix H pluses, H3O pluses with carbonate, CO3 2 minus, you're going to make, oh, that isn't any fun. Okay, so you're going to make another chemical reaction. Why is this a chemical reaction? The solid gone and there was a color change. That's bubbles that you can't see, right? They're up here, just a few of us, because we know that carbonic acid, H2CO3, is unstable and forms water and CO2. Which is what we made in here. The baking soda is hydrogen carbonate. Vinegar is a weak acid, but it still has H3O pluses, yes. And the H3O plus likes the hydrogen carbonate better than the acetate, so it makes carbonic acid. The carbonic acid is unstable and decomposes into water and CO2. It's not doing it right now because of what? Activation energy. It is still a spontaneous reaction because once I have, oh please say lit. Pretty please? No. Okay. All right. I've got several. So once it's lit, do I have to keep lighting it? No. Is it reacting on its own? Yes. So what type of reaction is it? Spontaneous. I love you guys. Spontaneous. All right. What's the delta G? Negative. Okay. Yeah. All right. Good. Okay. All right. So then, even though we didn't have a chance to talk about them very much this semester, we do have when you take elements, I guess we did this thick copy, but when you take elements and you excite them, so I'm going to do my 2 favorites. Well, it's a hard hard between, okay, I'll do my 3 favorites. So we got, when you take an atom or an ion and you stick it into a flame, you stick it into heat, just like you, if you jumped into that flame, you'd be hopping around too, so do the electrons, and so you get them to an excited state. So that's copper, all right, going to an excited state and coming back down again because it doesn't want to work that hard. And then we have these, you guys can tell me which one you like better. I can't decide whether I like strontium or lithium better. So here's strontium. Come on. Here's strontium. Okay, kind of salmon kind of color. I don't know why this is first. Wait, hold on. There's strontium. I don't know, then you might not like the lithium if you didn't like the lithium. There's lithium.
Yeah.
Yeah. So we'll just have a little here. We'll have a little have a little rainbow effect here, you guys.
Uh-oh.
I don't know how I can do that. Okay, so we'll just go through green and.
Uh-oh.
So that's So
how about all the colors together? All the colors, Kate?
Tempting. Okay, then we talked about when we got to kinetics, and this is where it makes a big mess. Okay, when we actually go faster if we increase the surface area, the amount of reactants interacting with each other at the same time. So you can take a great big, like a little cat falling off. Okay, so, okay, red cat hat. Okay, we know that actually what is occurring is the iron is reacting with the oxygen in the air. Yes or no? But we're going to speed up the reaction because we're going to increase the temperature. Increase the temperature, and we're going to okay, I'll just do a little bit more. So what's happening? An oxidation reaction. Oxidation reaction, yes. Was that a spontaneous reaction?
Yeah.
Yes, it was. It happened on it. Oh! Okay, now I got to really make sure I didn't spill this. This one is dedicated to this. Okay, all right. So, okay, so I have redox reaction.